So now I've got flowers with sine, still the same thing with odd giving you n odd giving you n petals, and even giving you 2 n petals. The range of the petals changes, and because it's sine, it's going to be symmetric with the y-axis. So here would be sine of 2 sine of 3 theta. I know it's going to have 3 petals, and so the range of one petal on this flower would be 0 to pi over 3. So let's just plug in angle 0. If I plug in angle 0, that gives me 0. And let's just plug in, they're not going to give me nice numbers. Anyway, okay, so then plug in pi over 3, that gives me sine of pi, that's 0 again. Okay, so I have to trust that this traced out one petal. So angle 0, and between 0 and you know the angle pi over 3 is here, right? So here to here, so in between, it must have come out and looked like this. So if I was to draw the other 3 petals where it would be symmetric with the y-axis, right, it would look like here and here, just to give you an idea. Not that I'm going to do that, but 0 to pi over 3 traces out one petal. Okay, so this here has 4 petals because n is even, and so from the angle 0 to pi over 4 traces out one petal. So again, you know pi over 4 is here, right? So between 0, and then if I was to do pi over 8, that would go out here, and then pi over 4 would give me that angle right there. So that gives you, so this is key to have access to know how to trace out the area of one petal. All right, so now let's move to calculus with these polar coordinates. Now we know what these functions will look like. Oops, I forgot the equal sign. So the derivative y prime will be the derivative of y with respect to theta over the derivative of x with respect to theta. Doesn't this look very familiar? Derivative y with respect to t over the derivative of x with respect to t. It is the same, only we're not having t's, we have thetas. Okay, the trickier and harder part about this is that before y was given to you in t land, y was given to you in t's, and x's was given to you in t's. Now we have to use what y is equal to. So remember that conversion factor, r sine theta, and x was r cosine theta. So in order to do this derivative, we need product rule. So it's going to be first times the derivative of second, plus second times the derivative of the first. The derivative of r is dr d theta. And down here, product rule again, first r, derivative of cosine, negative sine, plus cosine, and the derivative of r. Okay, nothing is ever going to cancel, so we just need to use it as it is. So these are my functions, right? This is my r, and it's got thetas in it. That's why I have product rule. So let me get rid of my little markings here so we can use this. Okay, so let's dig in. So my y prime, I see this is going to be like a limison. It's going to be the derivative of r sine theta over r cosine theta, so I can just use this nifty formula, all done for me. So r is 2 plus 3 sine theta times cosine theta plus sine of theta times dr d theta. Dr d theta is the derivative of this, so that will be 3 cosine theta, all over negative r, 2 plus 3 sine theta, times a sine theta, plus cosine theta times my dr d theta, which is the derivative of this, which is 3 cosine theta. Okay, there will never be any canceling here, so it's just best to go and just go plug in theta is pi. So this means the next step I'm going to do is put in pi. So I put in pi, so I'm going to go slow so I don't make a mistake. So I have 2 plus 0, cosine of pi I know is negative 1, plus sine of pi I know is 0, right? And then this gives me a negative 3 all over. So negative 2 plus 0, and then this will give me a 0, plus, and cosine of pi is negative 1, and this will give me a negative 3. So mistakes are made when you don't write the zeros down or you do too many steps in your head, so just be careful. So this is all 0. This here gives me a -2. This gives me a -2. Oh, but it's times 0, right? And then this gives me a +3. There it is. So the slope of the tangent line to this graph at theta is pi is this. So we can draw tangent lines in the polar coordinates.